My name is Mixel. I enlisted in the military in 1990 during the first Gulf War, where I stayed part of the 3rd Ranger Battalion for the next 20 years. So when I came home, I had a really bad transition, just shutting out and not being with my family. It was easier to just stay barricaded in our closet at home. I was at Bass Pro Shop and in walked a puppy raiser. So my wife got their business card and realized she's a puppy raiser for Patriot Paw service dogs in our backyard right here in Rockwall, Texas. And so I went on the waiting list. It took about 2 years to have a dog fully trained for me. I went from taking anywhere near 15 to 20 meds a day. I'm now on 0 medication. I didn't go to my kids' football games or get out and be a parent until I had Chief. And now I don't miss a single thing with my kids. So please help us continue this important work for veterans, and don't forget about Patriot Paw service dogs on North Texas Giving Day.
I'm Frank Berry. I'm with Doc, the B-29. I'm a crewman. I'm our historian. Been with the program about 8-9 years now. Anyway, we're here to talk about Doc this morning. So Doc is a Wichita-built B-29. Came out of the Wichita Boeing plant in December 1944. Flew for 11 years till 1956. Was given to the Navy as a target in 1956. They drug it out to China Lake Naval Air Station, shot at it about 4 times, and then they put it on the radar range so it would quit shooting at it. In 1998, Tony Mazzolini worked with Braniff, traded a B-25 for Doc because they wouldn't sell him a B-29. So they'd have a B-25 for their museum in Pensacola. So that's how he acquired the airplane. In 2000, they separated it onto 7 semis, excuse me, and brought it to Wichita, back to Wichita. And we spent the next 16 years restoring it to flight status. So we got the test flights out of the way in 2016. We've been flying on the air show circuit since then, so it's our first time here at Tyler, Texas. Okay, well, let's walk around the airplane and we'll talk about Doc a little bit. We'll start here at the nose wheel. A B-29 is an all-electric airplane. The only hydraulics on board are the brakes, and they're powered with an electric pump. So landing gear, flaps, everything is operated electrically. Flight controls are pure muscle. There's no boost on the flight controls. So it's just you and your co-pilot. If you need boost, you slap the co-pilot, tell him to pull harder. So aircraft of this era did not have steerable nose wheels. So these are a cast ring nose wheel. This is the centering device. There's a big spring in here with a racetrack at the top and a wheel that follows in the racetrack. There's a divot, and when it rolls in that divot, it centers up the nose wheel so that it goes up in the wheel well. This is the Shimmy Damper, operated through this lever, filled with 5606 hydraulic fluid. And then it wasn't until the B-50 post-war that we put steering on these aircraft. So the nose wheel well, crew hatch, they came up the side of the nose wheel well. We've put a different ladder in to make it easier for passengers and crew to get in and out. None of us are spring chickens. Wartime crews were 18-year-old kids, so they could do a lot of things that us older folk can't quite do as readily. So we have a single pitot tube on this side. We'll go down here. We have a large air inlet here. The engines were turbo supercharged, so they had turbochargers, dual turbochargers that took intake air, fed them up through an intercooler, and then into the engine through the internal supercharger. So wartime boost was about 56 inches of manifold pressure. We don't use the turbos anymore. We just use the internal boost at about 44 inches. The inboard engine turbochargers also provided the cabin pressurization and cabin heat. So they fed hot air through an intercooler in the leading edge of the inboard wing here. Ram air came in through this duct. You could mix it or dump it straight into the cabin. And it went diffused down the tunnel fore and aft. There were ducting there that could take the hot air up and heat the windshields for when they were de-iced. The propellers are 16 foot 9 inches. These are original Hamilton standard propellers, the largest production propellers in the world. They had alcohol slingers for de-icing in the war, and rubber de-ice boots, which was pretty standard, pretty common for de-icing the wings and tail surfaces. So these are Wright 3350s, 18-cylinder radials, 2 rows of 9. Each cylinder is about 3 liters in displacement, so you can compare that to your car. Pretty good sized cylinders, about 6 1/8 inch in diameter, so quite large. They produce 2,200 horsepower at sea level, and back in the war they could maintain that up to about 32,000 feet. So service ceiling on a B-29 with the full payload, which was 20,000 pounds of bombs, was 32,000 feet. So this airplane spent more time in wind tunnel testing than any other aircraft up to that date by a significant factor. Particularly the engine cowlings were designed to absolutely minimize drag and maximize cooling because they needed to be able to get 4,000 mile range, and this was the first aircraft in the world that could go 4,000 miles and ultimately carry a full payload. Air inlet on the bottom is the intake air. Some of the air goes on through the oil cooler. We can see the oil cooler duct coming out the bottom of the cowl. And then the last third of the air went up and out the top of the nacelle through the intercooler, cooling the compressed air from the turbochargers. They're rather large oil coolers. Again, you can see up here in the wheel well, it's a giant jack screw. Electric motor up here that drives the gearbox and drives the Acme screw here. And this literally just extends, unfolds the scissor, pushes it up that way. When the gear gets up near the top, pin here grabs the actuator arm up there, and that closes the gear doors. We have fire suppression bottles on either side that they can be used both for one engine or can be separated and used on either engine. So, and same thing on the left-hand side. So. But we cannot cross-feed the fire suppression to either side. We can carry about 5,400 gallons of fuel in the 11 fuel cells we have in the wing. There were 2 more fuel cells available in the wing inside the fuselage. We did not put bladders back in those. They have about 1,400 gallons apiece to bring the total capacity up to 8,000 gallons. We jokingly refer, when we have public tours, we're talking about the airplane gets 2 gallons to the mile, not miles per gallon. 8,000 gallons divided by 2 gives you 4,000 mile range. So we don't do much differently today. The aircraft was really designed with high efficiency back then. We just do it at about 10 or 15 miles an hour faster because we don't have the payload of the weight of the bombs or the guns for drag. So, but we still get about 400 gallons an hour in cruise. We just do about 215 miles instead of 200. So just a little bit faster, but we still, same fuel burn per hour. So yeah, it's a pretty amazing machine. Virtually all aluminum. Steel components obviously in high strength, high stress areas. The nacelles, you can see parts of the nacelles. Since our aircraft is polished, they were basic bare aluminum in the war. First use of alclad was used on B-29s. You can see a slight color variation in the nacelles. So the slightly darker polished portions are stainless steel. The lighter portions are aluminum. Stainless was used anywhere where there was a higher heat concentration. So the original engines, the forward cylinders exhausted forward. So there was a red hot exhaust collector ring just behind the nacelle. So that nacelle had to be stainless steel to handle that hot heat. Then that ducted down each side, connected with the rear exhaust collector full ring again, and then traveled down either side to the 2 turbochargers. And then the intake is balanced internally, goes up through the intercoolers, and then separates and goes into what we call the ram's horn into the top of the engine. War engines were fuel injection to eliminate or reduce the intake fire problem. Post-war engines which our variants are of that variety. We're back to carburation because it's a lot easier to maintain and work on. So post-war engines, on a B-29, the aft section is from a Skyraider, which has a larger blower locked into a single speed, because we just use the turbo or the supercharger for our application, and that will actually bolt straight onto a B-29 engine mount. And then the power section with the cylinders is from the Constellation era, a later variant. They redesigned those cylinders. The rear cylinders exhaust to the rear, and the forward cylinders now exhaust to the rear. They snake the exhaust around between the heads of the rear cylinders, and we collect all the exhaust behind. So these engines run significantly cooler. And our custom exhaust on dock is actually 2 halves, so it's not a full ring. It's 2 halves, inboard and outboard, and so they go out the wastegate duct. The flight hood from the turbocharger is just there for looks. There's no turbo components on the airplane. It's just a straight pipe that goes out what would be the wastegate duct. So it has a little different sound because you're really only hearing half of the engine at any one time. So it's very low maintenance and works very well for us. That's the flight hood there, which was the exhaust from the turbo. The wastegate behind, you would close a valve in the wastegate, forcing more air through the turbocharger to spool it up to give you your higher boost. So, outboard engine here, they're the same. You can see our cowl flaps are open, and so you would open and close those to regulate your cylinder head temperatures. On the ground, they can be open to 25 degrees. For takeoff, they need to be 12 degrees or less, preferably 10. And then normally we have them at cruise, they're close to 0 to 1 or 2 degrees. Typically, they stay pretty closed. And you open them up to 10 degrees in flight, and you'll feel a really good buffet in the tail. And you'll lose about 8 miles an hour. It's amazing. And that was just with one engine. If you do that, yeah, they produce a lot of drag. Yeah, so the wing is 141 feet 3 inches tip to tip. There's 11 fuel cells in the wing outboard of the fuselage, 7 dedicated to the outboard engine, 4 for the inboard engine. There was no cross feed available from within one wing to within the other wing. Crossfeed was used by taking fuel from one of the 7 tanks on the outboard engine or the 4 tanks on the inboard engine, taking them to one of the centerline tanks, and then you could pump it back out to any of the other tanks. But you could not go directly from tank to tank. So we have no cross-feed capabilities because we don't have the centerline tanks. Fifi's no different. We've got little catch bottles here. When the engine shuts down, the supercharger case drain, in case there's water in there, overnight, we'll run out that drain. A little oil will come out of there after engine shutdown. We just try to be environmentally friendly, and we have a little cup that can hang on there and collect the oil that drips out. We're trying to be friendly. That doesn't mean that we still don't mark our territory. These are still round engines. If they're not leaking oil, don't fly because there isn't any left. So in the nacelle, in the back of the nacelle, is a 90-gallon oil tank. It was normally filled to 85 gallons for a mission. Wartime consumption was 3 to 4, maybe as much as 5 gallons an hour per engine. So they were out of oil at the end of a 14-hour mission as much as they were out of fuel. So yeah. So modern engines, the modern variants, burn about 1.5 gallons an hour. That's pretty consistent for us across the board. Some ooze a little more than others, some burn a little more than others. So, but they're all pretty consistent at about 1.5 gallons an hour. That's the nature of the beast. So you've got about 25 feet of aileron out here on both wings. Both wings have a trim tab. It's preloaded 1.5 inches trailing edge down, which puts a preload on the aileron. I'm assuming that was partially done for damage tolerance in the war, so that the aileron had a preload and wouldn't flutter. So the airplane basically has a triple redundant system for the ailerons. The pilot's yoke controls the left-hand aileron, the co-pilot's yoke controls the right-hand aileron, and then there's an interconnect loop that connects the two. And then the trim systems are independent as well. So elevator has dual cables, both pilots go straight back to the elevators. But one interesting design feature on the B-29 is that the left-hand elevator trim tab is interconnected to the flaps. So as the flaps come down, they automatically drive the left-hand elevator trim to keep the pitch forces basically neutral. And then the pilot controls the right-hand elevator trim tab. So if the flaps are down, you can have somebody come by and go, "Your elevator trim tabs are all wonky," because one will be up and one will be down, but that's because one was driven by the flaps. So they're actually separate. So the flaps are a Fowler flap, and they're 40 feet, single piece flaps. They run from the edge of the aileron all the way to the fuselage root. So we have more wingspan and more wing area on a flap on a B-29 than a 172 has a whole wing. So we use 15 degrees for takeoff. Wartime used 20 degrees. We have marks on the top of the flap that are visible to our scanners in the back at 15, 25, 35, and 45. So 15 is our takeoff requirement. 35 or 45 we use for landing. 35 gives you a little bit more flexibility in your air speeds and energy management. But if you need to get in short, 45 will. There's a lot of flap hanging way down. So dual mains. Boeing was pretty smart. Rather than redesign things, they just figured out how to reuse stuff. So the wheel, brake, tire assembly is the same thing on a B-17. It's just doubled up. So we use two sets of wheels and tires and the same brakes. So all those components can be used elsewhere, so they didn't have to design extra stuff in the war. We can still get new tires from Dunlop. And since that the tire is used on 17s and 24s, we can pool our resources in the warbird community and order them in batches from Dunlop. Dunlop also has the molds for the nose wheels, but the mold is privately owned. The only mold that they have is the cross diamond pattern, which was pretty common in the war for particularly grass strips. The nose wheel is actually a P38 main tire, and one set of rims that was used on the B-29 is actually the main rim on a P38 without the brake assembly. So our other set of wheels is P38 mains, and they use the same tire, and then A26s use the same tire. So again, now post-war, when parts are harder to come by, we can pool our resources and order them in bulk from Dunlop. So that comes in kind of handy. The wheel tire assembly weighs well above 500 pounds. Our scale quits at 500, so we don't know exactly what they weigh, but well above that. You don't want it to fall over on your foot, that's for sure. We run 65 psi inboard and outboard on the mains. We run 50 pounds on the nose, and that really gives us pretty good wear. We've kind of learned over time what works. Every airplane's just a little bit different, but that gives us pretty consistent, even tire wear on dock. So weight on wheel switch back here. The nose gear has one too. So the gear will not retract if that is not made, or in this case is made if the wheel's still on the ground, or if that arm breaks, and then the switch is spring loaded, so it will think it's on the ground, and so you can't get the gear up. Safety feature. So 2 bomb bays, forward and aft. A fixed section in between under the center of the wing carried the onboard radar when it was there. The bomb bays are, for all essential purposes, the same dimensions, and with a 10,000 pound capacity in each, that gave you your 20,000 pound total payload. So we'll open these up for our cockpit tours. We have a ladder staircase that was built by Boeing employees to facilitate the tour, so we'll drop that down. It stows inside the bomb bay. We'll bring our tour people in through the aft end of the forward bomb bay, up the stairs. We've got some bombs in there, a 1,000 pounder, 500 pounder, 250 pounder, so people can get a size comparison. They'll go through the cockpit and come down the forward ladder. So that works really well for passenger comfort. Little hole here is just a vent for the aft bomb bay. Similar holes in the front for the forward bomb bay. Cabin pressurization was maintained through two outflow valves here in the aft section. Bomb bays were not pressurized. Again, this was the first production pressurized aircraft in the world. So the forward cockpit section from the edge of the bomb bay forward was pressurized. The gunner's compartment from the aft end of the aft bomb bay to just forward of the entry door, that section was pressurized. There's a tunnel 27.5 inches in diameter and 31.5 feet long that interconnects the two main compartments at the very top of the fuselage above the bomb bay. It's open at both ends, so it's part of the pressurization system. But all the air is controlled by the two outflow valves in the back here, and they just dumped their overboard air into the aft bomb bay. So they were not sealed. There was a rain seal on the edge, but the center, there's a gap in the center, so you can see right down through it. So manual gear and flap extension is accomplished inside the aft bomb bay. There's a catwalk right at the back spar, and the flap motor is mounted there. There's a crank housing on either side of the fuselage. You can put a hand crank in, or the standby flap motor is actually on a handle with a long cable. So you disconnect it with 4 big quarter-turn wing nuts and move it to either side, snap it into place, and you can run them electrically from inside. Or if that were to fail, you had a total electrical system. There's a hand crank. It's 387 cranks from stop to stop. So you get tired after about 50. Aircraft standard 28 volt DC system. The external power port here. There's also another one in the nose wheel well. So the aircraft used 3 basic voltages. 28 volt DC was pretty standard throughout the airframe. And we had a 115 400 hertz AC system for instrumentation. And then there was roughly a 50 volt 400 hertz system that ran the turrets, the gunnery turrets, and some of the other computering systems that were on board. So one of the interesting things, this was the first aircraft to use onboard electronic computers. So the gunnery system was very unique. It was the first aircraft that used a remote gunnery system. So there were gun sights in the 2 side blisters and the central fire control seat at the top, which is the yellow tinted bubble like sunglasses. You can kind of see the seat through here. It spun like a barber's chair. That's what we call it, the barber's chair. And there was a gun sight mount at the top that spun with him. There were gun sights in these side bubbles. So you looked at the enemy aircraft. Wherever you sighted the aircraft, appropriate turrets followed. Each gun sight could grab 2 turrets on its own, but the central fire control gunner had access to all of the turrets and could feed them to whichever gun sight had the best view of the oncoming enemy aircraft. There were 5 vacuum tube clockwork mechanism computers in the belly of the aircraft called Parallax Computers. They made all the calculations to put the bullets on target. Lead, drop, everything. They measured air temperature, current airspeed of this aircraft, humidity, had 2 gyros on board so that as you tracked the aircraft it knew your rate of elevation and rate of turn, and fed all that information appropriately. Considered about 10 times more accurate than hand shooting. Good estimates are 80% accurate at 1,000 yards, above 90% at 800 yards, and the Japanese bullets, metric equivalent of about a 303, couldn't even reach us till 750 yards. So This was not an airplane you wanted to tangle with. We only lost 148 to combat in the Pacific Theater, and we had 2,000 bombers in actual combat during the war. So unlike Europe, where you might have a 1,000 bomber raid over Berlin, we had 1,000 bomber raids consistently over Japan, but they were scattered over a dozen or more targets. So you might only have 100 to 150 aircraft on any one target, but you might have 10 targets that day. So yeah, huge difference. This was the aft entry. There was a wooden trapeze ladder, did not reach the ground, similar to what you see here. This is an extension ladder. We can fold it out. It makes it much easier for passengers and crew to get on board. We did wire the aircraft with a 110 ground power system, available only on the ground with the external power. Run some lights, fan, to try to keep people a little cooler. But there's no way to keep it or to connect it to anything on board. So it's just for ground use. Wartime aircraft used APU called the Putt-Putt. Sat back in this unpressurized compartment. You can kind of see it right there. Little 2-cylinder Fairchild generator. Officially rated at 175 amps, but it would put out closer to 200. They just used a single battery in the war, and wartime engines didn't start generating till well above idle. So the Putt-Putt provided the electrical needs on the ground, and actually well after takeoff they didn't turn the generators on until they were actually in a comfortable climb. They didn't want to add any electrical or any other loads to the engines to help keep them cool, because they ran so hot in the war. They actually did the mag check on the takeoff roll because they didn't want to induce any other heat. So underneath here was a mission camera. The camera mounted back here in the unpressurized compartment, but you could open the doors through a lever inside the pressurized compartment and then trigger the camera electronically, and so you could aim it and it could take post-mission or reconnaissance photos. There were dedicated reconnaissance aircraft that had reconnaissance windows built into the bomb bay doors and some other places as well. This was the location of the lower aft turret. All 4 turrets hung out about 14 inches from the aircraft, just enough for the guns to traverse horizontally and follow the fuselage line. They had 360-degree swings and can actually traverse slightly above or below the horizon, depending on whether they were top or bottom. They're all in line on the center line of the fuselage, so they had full 360-degree views. Tail skid back here. Shock absorbed, steel plate, replaceable, designed really to protect that aft tail turret. So it gets bumped once a year in training, typically, not uncommon. We'll never wear this one out. In the war, if you hit the tail skid as the pilot, you had to buy the crew a beer. So we haven't gotten our beer yet. Later aircraft were fitted with radar altimeter, and that's where this antenna was. Keybird was a B-29 that crash landed in the war on Greenland and the ice, and in the process of trying to recover that APU caught fire and burned up the airplane. So Fifi has a dedicated fire suppression system for their aircraft to ensure that doesn't happen. We opted to put in 3 batteries, and so with 3 full-sized aircraft batteries, we do not need to run the Putt-Putt at all. It is connected to the aircraft system. We don't keep any fuel in it, so there's no fire hazard. And our 3 batteries will give us all the electrical needs we need. Plus the modern variant, it's called a hybrid. The engine variant that we use, the generators come online basically at a high idle, so we don't have to worry about keeping them offline or anything like that. So all of our electrical needs are supplied by that. Reduces our fire hazard. Full span aileron or elevators back here. When you can get up close, you can really see that the bottom side of the stabilizer has a very high curve to it, and the top side is almost flat. So it gives you some idea of the downforce that the stabilizer is putting on the airframe. All the flight controls, ailerons, elevators, and rudder were all fabric covered. That was for damage tolerance. A bullet going through a fabric cover will just make a clean hole in and a clean hole out. It doesn't take much material with it. If it was a metal surface, it would not only change the aerodynamics, but change the balance. Balance and aerodynamics are critical on flight controls, so if not, they can get into a flutter and they will literally tear the airframe apart. So that was pretty common back then. They could easily be patched and kept in service very quickly. Tail turret back here. All the guns on a B-29 are 50 calibers, Browning 50s, 500 rounds per gun. A Browning 50 will shoot about 680 rounds per minute. So you had about 48 seconds of ammo on full auto. But the gunnery system on a B-29 only required 5-second bursts or maybe 10 round bursts because it was that accurate. So you really didn't need high rates of fire. So your ammo lasted quite a bit of time. The guns would traverse up and down and the ball could rotate left and right. It's outside of the tail gunner's pressurized compartment. He would crawl back to the tail and then he had a little hatch and he would close that hatch and then his compartment was pressurized. So once he was back here and closed that door and they pressurized, he would be trapped until they unpressurized. Most of the aircraft commanders we've talked to, crew members, things we've read, they actually unpressurized for combat so that bullet battle damage would not be as catastrophic. And there were actually patch kits on board, so if they just had a bullet hole, they could peel back the insulation and plug it with a wooden plug or a rubber patch and repressurized afterwards. So, yeah, pretty cool stuff. This was the chute for the tail gun cartridges. It was normally open. We closed it off. This tube here we added. We've got a system on board that uses pressurized air, and we can scatter veterans' ashes using this system. So it works very well, keeps the airplane clean, nice and efficient system. So that was not a normal, the chute was, but it was open, but that part was not. The lower turrets all ejected their cartridges overboard. The upper turrets ejected them internally into a bowl in the bottom of the gun turret. They were sealed because three of them were inside the pressure vessel. So afterwards they unclipped that bowl and they could scoop all the cartridges out. No one could touch a gun on a B-29. So they were outside, they were in sealed compartments. So even the aircraft later in the war, when they took the guns off the B-29s, either out in the field or didn't put them on in production, the tail turret was standard equipment on every B-29. So even the silver plates, like Enola Gay and Boxcar, had tail guns, but they didn't have any of the other guns. So crankcase vent for the putt-putt APU and the exhaust vent, it just burned air from inside the tail compartment. So and it was in a non-pressurized area. So escape hatch here. The tail gunner had a little door in an emergency. He could pop out of the escape hatch. One major difference between Doc and Fifi, and we haven't researched it enough to determine the exact reason. We know Wichita built Doc in December of ⁴, and Fifi was built in Renton, Washington in July of '45. Her bubbles are permanently attached to the airframe, so to replace a bubble you have to drill out a lot of rivets. The bubbles on Doc are removable, 4 handles. They pull into the aircraft. We also have defog fans that, to my knowledge, are not existing on Fifi. They just were 2 fan blower motors in the belly. Would take warm air and blow it on the bubbles to defog them. Works great for us because we can use that air like a cooling fan. So one other difference between us and Fifi, or us and a war-ready aircraft, the scanner seats actually faced aft, so they sat on the forward side of the bubble. Your feet are actually in a well down below the floor, so the seat's actually built into the floor. We didn't want to have people turning around for passengers. That tended to increase air sickness. So our seating configuration is Boeing's weather reconnaissance seating configuration, and so their seats face forward. Basically, if you take the seat, turn it 180 degrees, move it to the other side, all the components bolt in. We face forward, and it makes it a little more comfortable, a lot easier for us to observe the aircraft, because our job as scanners now, we're not looking for zeros coming in after us, but we are monitoring the engines. They're still 18-cylinder radials that spew a lot of oil and smoke, and we don't want to see smoke and fire and the things we don't want to see, and that's our job. We confirm flap and gear position settings. So we've got a red reflector here on the back, which we can line up with a white line on the drag strut. So from our perspective inside the airplane, when those are in alignment, the gear is down and locked. And then they have indicator lights in the front as well. And we look for oil leaks in case we broke a brake line or something else. Strut, you know, was leaking oil or things like that. So all those are items that we can observe from the back. So out here on left-hand wing, all of our lighting has been converted to LEDs just because it will last forever. Except our landing lights, they're retractable, one on each side. So when you turn the light on, this pivots down and aims forward. One closer for taxiing and one further out for the landing configuration. And the light comes on when it comes down. Then when you retract it, the light goes out as well. So for two lights, they really light up the runway environment. It's amazing how bright they are. So this aircraft was an all-weather aircraft. Flew full instrument approaches back in the day when it was just being developed. LORAN was developed in World War II specifically for the Pacific Theater. So early LORAN, which we're now phasing out in lieu of GPS now. So in fact, we were joking the other day, we have 4 onboard GPS sources tied to the current avionics, which is Rockwell Collins gyros and Garmin Navcom equipment. But everybody carries a cell phone or an iPad for backup. They all have GPS sources. We use 4Flight, it's pretty common. We counted up the other day, we had 17 GPS sources on board. So we're not lacking for navigation capabilities. On top of the wing and down the center line of the fuselage are recognition lights. I believe they're all blue on this aircraft. Sometimes they came in red or green. They were used for formation flying at night. Couldn't see them from below, so the enemy aircraft couldn't find you. But in formation, you could find your mate and keep proper distances. You could use that configuration, basically a X configuration. So spotting on the number of lights, you could determine your proper position in formation at night. They also weren't bright enough to be revealed at long range. So again, we didn't have to worry about most of the Japanese fighters couldn't even get up to our altitudes. Those that did really had to do head-on attacks because no one was as fast as we were. So being spotted from above was virtually non-existent. Later on, when we did go to night bombing, they painted the bellies of the aircraft black just so they wouldn't be, and the nacelles, not the wings, just the fuselage, so they wouldn't be seen as rapidly. And then they painted the cockpits either olive drabs or that was pretty common, just to eliminate as much reflected light as they could. Because we were at altitudes that Japanese aircraft could get you when we went to firebombing. But the aircraft could go 367 miles an hour top speed. So that's 100 miles an hour more than B-17, about 75 miles an hour more than a B-24. Realistically, there were only between 8 and 10 fighters worldwide that could keep up with a B-29. Half of them were ours. 2 were German, we didn't have to worry about those. 2 were British, we didn't have to worry about those. So 1 or 2 Japanese fighters that were almost purpose-built were really all we had to worry about. They learned early on not to tangle with a B-29. So they soon resorted to suicide tactics if they could get above the bomber fleet. Typically not till we were on the outbound leg after the bombing mission, because they didn't have early warning radar. They would dive down through the fleet and try to take out an aircraft on a suicide mission and hope the debris took out somebody else. But we only lost 148 to combat in a year and 2 months of combat. So pretty impressive record. You're actually 5 times more likely to die in a non-combat accident, engine failures being the most common, than you were in combat. Your percentage of lifespan was almost identical to Europe, but the reasons for dying would have been totally flip-flopped. So, yeah. A lot of people don't know we lost, 8th Air Force lost more airmen than the Army did taking Europe. If you want to get a quick shot, we've got both bomb bay doors open now, so you can get an idea of what the 2 bomb bays would look like. And the bombardier had a computerized section that he could set up to configure the bomb release, so they would stagger them left, right, forward, and aft to keep the CG consistent. You could also salvo them, or you could do a full bomb release if necessary. Everything went at once. A salvo would be you lost an engine, low altitude, you needed to get rid of 20,000 pounds. There's a salvo button in the back as well as in the front. You just hit that, everything released. There's a safety wire cable that goes through the bomb shackle and goes through the fuses front and rear on the bombs. When you salvoed the bombs, that wire stays with the bomb, so the fuses can't spin and go armed. When you normally release the bomb, that wire stays attached to the bomb shackle, and then as the bomb falls away, the wire pulls out of the fin. 200 turns approximately of the fin arms the fuse, so it would fall 500 feet or more below the aircraft before it actually became armed. So we'll head on back in through the bomb bay. So we'll just duck down here. We've got a spare oil tank, just so that when we're out on a long trip, we don't have to try to figure out how to bring a barrel of oil with us. We can just put it on board and pump it out with an electric pump on the ground when we need to. We've got 2 bomb racks here. Normally there were 3 to 5 racks down each side of each bomb bay, depending on mission requirements. We have an example of a 1,000-pounder, a 500-pounder, and a 250-pounder, so you can get a size comparison with the most common ordnance that was carried in the war. And there's our tunnel that connects the 2 compartments. So you can see all the flight control cables. There are the high ones. Engine control cables are the low ones. So those are all the cables that manually control everything on board the aircraft. And we'll just head right on up. You duck your head, put a leg through the hatch, and then your body. It works out really well. Lower turret was here, twin 50s down there. Upper turret was here, quad 50s in the forward upper turret. So 1250 calibers, 6,000 rounds total on board the aircraft. Radio operator sat here. We've moved his seat just for convenience. It sat literally right over the edge of this lower turret, which came up to this elevation. And the upper turret came down almost to the same point. So when the turrets were installed, this space was completely filled with gun turret. He couldn't actually see anybody else in the compartment. So navigator sits over here. Back in the war, his table folded on a 45, so you could actually sneak around the turret to get forward. And this upper cabinet was not installed at that point. Hatch would have been closed. The jump seat would have been a stack of navigation radios. There was a map case along the side, some navigation instrumentation on the front end of this table, a navigation plotter, which we've been given one. It's on display back in our hangar in Wichita. A friend of mine's dad was a navigator, and kept his plotter, and he donated it to us. So we've actually got a wartime plotter. The main brake accumulator is under this hump as with the hydraulic pump and associated hardware. The tank is here. Gravity feeds to the pump. Normal pressure is 1125 plus or minus 100. Deboosted at each wheel set down to about 300 working psi for the brakes. They're expander tube brakes, 16 brake stacks between. There's 2 outboard and 2 inboard on each wheel. So the KC-97, which followed the B-29, same wing tail group, Pratt engines, actually only has half the brakes that we do, and that was still plenty. So it was all tube radios, fixed radios, fixed frequency radios such as this. Normally across the top there would have been a stack of 5, 3 receivers, 2 transmitters. You have a 5-band tunable transceiver down here, which was very common. And then where the seat was a floor mounted, later in the war, with a memory, an automatic tuning radio transceiver with a memory. So once you set the frequencies, when you shut it down, next time you turned it on and the tubes powered up, it reverted to the preset frequencies. There were also flex drives that came up to the back of these radios and fine-tuned the fixed tune radios to the frequencies. So it was a very automated system. Emergency accumulators there, powered by the same pump but separate with a separate fill valve and isolator valve. So if the main brakes were damaged, you still had emergency brakes. So again, navigator sat here. He would also climb up into the bubble right above us here. There was a framework that sat on those brackets there on either side and forward. He had an astro compass or a sextant that would mount in there, so he didn't have to hold it in turbulence, and he could use that for sighting on the sun or sighting on stars for navigation purposes. And again, LORAN was added later in the war. And then they also had ADF, the black antenna you see right through there in the teardrop is the ADF antenna. It's just a wire loop. It's in a fairing because at 367 miles an hour you just bend the wire. And it needs to rotate to home in on the frequency. Radio operator used 3 means of communication: air-to-air voice, air-to-ground voice, and air-to-ground Morse code with the Morse code key, and that was all coded. So that used a regular code as well as Morse code for the long range. And the radio operators got to know each other's tapping foot fingerprint, so to speak, signature. And so the Japanese were pretty adept at trying to fool us by sending out false signals. But most of the radio operators figured out that's not Joe, must be the Japanese, that's not Joe's fingerprint tap signature. So we've got a little map here that shows Marianas are down here, Guam, Saipan, and Tinian in that order, flying 1,200 miles all the way up to Japan and back. So average missions were 12 to 14 hours, roughly 3,000 miles. Longest mission of the war, a friend of mine, he's 97, he flew that mission. It was an 18-hour mission. The last night of the war, they were still 2 hours from home when the surrender announcement came over the radio. Yeah, so they flew to the northernmost point that we bombed in the war, which was Akita, 175 miles north of Tokyo on the main island. So pretty impressive stuff. So that's the nose hatch that you go up through the nose wheel well. Flight engineer sits here if you want to head on up there, get some good pictures. He manages the aircraft, so he's got all of these controls to to manage all the systems on the aircraft: electric, hydraulic, fuel, pressurization, vacuum systems, all of that. All these gauges are dual gauges. So anything engine related has 2 needles, either for engine 1 and 2 or engine 3 and 4. I like it because it's easy to pair up engines. You can just match the needles, whereas later variants with 4 gauges per engine made it a little more difficult. He's the only one that can start and stop the engines, so he has mixtures, throttles, boost pumps, all of that is available to him. Pilots have throttles, which they use for ground steering, again because it was a cast ring nose wheel. Otherwise, he gets them started, gets them warmed up. Pilot will take over, taxi us to a hard stand where we do our run up. He'll taxi us back out on the runway. Typically our process is we come to a stop, flight engineer stands them up to 30 inches of manifold pressure, which is slight boost. Make sure the engines are stabilized, hands it back to the pilot who will walk the throttles, advancing them and using a little bit more left than right because there's a left turn tendency on takeoff. When it gets to about 80 and the rudder becomes effective, he'll typically be between 35 and 40 inches of manifold pressure, and he'll say flight engineer's throttles, max power. We'll bring them up to 44 inches of manifold pressure, and it's our airplane until we land. So they just call out power settings and we provide it. So we call it auto throttle, audio throttle. Okay, so pilot's here on the left. There's his throttles. Aileron trim, rudder trim, elevator trim. Here in the center console we have the emergency brakes, feathering buttons, navigation lights. He does have propeller pitch control switches. They're controlled electrically and actuated hydraulically using engine oil, which was the standard practice for Hamilton Standard. Otherwise, the flight engineer has a separate set of switches that he normally does. Bomb bay door controls here in case there's damage or the bombardier gets injured or whatever. Boost for the turbocharger. Single knob controls all 4 engine turbochargers from 0 to 10 boost. This was the autopilot control head here. Very advanced for its day. Co-pilot here on the right has basically matched controls. The only real difference is gear, propeller, flap indication is all here on the co-pilot's panel. You've got manifold pressure and RPM gauges on the pilot's panel. Otherwise, they're pretty much similar panels. And then forward, we have the Norton bomb sight, which on a B-29 was highly computerized. You set the bomb sight up, you tracked to the target. The bomb sight actually flew the airplane on the autopilot. The bombardier only had to continue to track to the aiming point. The bomb sight opened the bomb bay doors and released the bombs automatically because a half a second delay in bomb release could be 1/10 of a mile or more downrange. So timing was very critical. And then he had a gun sight when guns were installed, which they were not on dock. And that's the gun sight there to the right, just in front of the co-pilot's instrument panel. The big lollipop lever there on the side is actually the trigger. There's a gyro on the top and another one on the bottom that fed information to one of those 5 computers. So, very impressive system. Airplane was normally climate controlled, not air conditioned, but certainly heated. Shirt sleeve environment, just like flying in an airliner today. Had an 8,000 foot cabin at 32,000 feet. They unpressurized for combat. Again, battle damage would be lessened. If they were going to have to fly extended periods of time, they all had a heated flight suit on board. They typically didn't all wear them. Typically 1 or 2 would wear them. And they could plug those into boxes like these where everybody's stationed. And they were a 28 volt or 24 volt system that you could then set the temperature and keep yourself heated when the airplane got cold. But one advantage was you could actually keep the aircraft heated unpressurized because you could just bring in the hot air and dump it overboard. So even in combat, they still had a lot of heating capabilities. But that came from the inboard engine. So if they lost inboard engines, they would be limited on pressurization and cabin heat. So That's pretty much the forward end, the hand crank here for the nose gear if necessary. It had a separate switch on combat aircraft. You could lower the nose so you could then pop the hatch and just dive out through the hatch if you had to parachute overboard. So here's a good picture of the tunnel. So again, 31.5 feet long, 27.5 inches in diameter. You can comfortably crawl through that even wearing a parachute and a flight suit. Yeah, even in turbulence, you can just arch your back and slide it along the top. The whole aircraft was insulated, so there was a diamond quilt insulation blanket throughout the aircraft. Even in the tunnel, all of that had long since deteriorated, so we've just put aviation carpet. Cessna donated to us for that, so saves your knees a little bit, crawling in and out. So we don't normally let passengers do that in flight because we could then end up with too many passengers in one end and not enough seat belts if we had an emergency. But as crew, we'll do it. Pretty common, so because we know how to get back quick. Every crew station had a headset, so there was a complete aircraft intercom. It's not as loud inside as you would think, and it would have been significantly quieter when it was insulated and pressurized. So, a very comfortable airplane to fly. Watch your head when you step out because the tunnel's right there.
It's like a pit. They actually...
This ladder system works very well for our application, so it makes it very easy for passengers to get in and out, front and rear. We can make them up from an existing extension ladder, so they're easy to make and replace. And they work very well. We pull them up and stow them on board, so the ladders are always with the aircraft. The yellow handles existed, they're right here above the pressure door. The yellow pole did not. Again, we've added that for ease of access. I'm going to move this. So you are sitting in our aft scanner seat. That would not have existed in the war. There was no seat here. Everybody was in the forward compartment. The ring is the top of the lower turret and came up 12 inches, maybe even a little bit more above the floor. So you crawled around it to get to the tail gunner's position. So this tail compartment was unpressurized, but his little hatch was pressurized. So when he crawled through that door and would close the door behind him, he would then be sealed in his compartment until they unpressurized. So we have a gun sight back there, a spare battery in case we need it. On a ride flight, our passengers can crawl back there, spend a few minutes, get an idea of what it's like to see the world go by backwards at 200 miles an hour. Imagine themselves being in that position for 6, 7, 8 hours at a time. So this is where the 5 Parallax computers sat, one for each gun or one for each turret, depending on how you wanted to look at it. But all interconnected, so again, the system was very versatile. You could have everybody aiming at one enemy aircraft, and then a turret from another part of the aircraft sees another enemy action coming, and he could grab up to 2 turrets on his own. So the system was highly versatile. Boxes up here on the ceiling next to the center fire control gunner who sat in this seat kept count of the bullets per gun, so you always had a count of how many you had remaining. And so again, it was a very versatile system. Bailout bell, warning buzzer. Again, our bubbles are removable. You can see the 4 latches. The only difference being we've got our seats facing forward instead of facing to the rear. If you want to step down in that well, Put your camera all the way out till it touches the window. That window sits outside the aircraft by 18 inches, so you can see over the wing, over the tail, straight down below to the ground, or straight up above. So it had incredible views of enemy aircraft coming in. It was considered a very, very versatile system. So those are the super secret flat screen TVs from 1944. So as we jokingly say, that and the USB ports. So the two TVs that we have installed, since the passengers back here have very limited window access for the takeoff and landing phases because they're not sitting in these side seats. This left screen, we have a camera view out the bombardier's compartment, so they can see out the front of the aircraft. And we put a moving map on the right side so they can get an idea of where we are. It really enhances the passenger experience in the back. Original central fire control seat. So if you want, you're welcome to sit up in that. Just kind of stand on here, plop your butt into it. It was an extremely impressive system. Again, this compartment was pressurized. So good creature comforts back here. Our pressure door into the aft bomb bay is right here behind the step ladder. Our two black cone objects, one on either side, are the outflow valves that control the pressurization. The old original Air Research pressurization valves. We're no longer pressurized. Two reasons. One, we don't need to go high. And we don't have turbochargers anymore, so we couldn't pressurize if we wanted to. We also don't have cabin heat, so we're limited on cold days. But they don't do air shows when it's cold, so we use those winter months to do our annual inspection and major maintenance on the airplane, so it works out well. So, but an amazing aircraft. Again, you can see the flight control cables back here. So they're moving back and forth in flight as our pilots do their thing. Wire bundles. And this is a custom wiring harness for the aircraft. The wires were gutted because someone, when it came out of the desert, thought they were asbestos coated. They were cotton and they just yellowed in the sun. So they gutted all the wiring, which was actually a good thing, because then when we went back with a custom harness, we only had to put the wires in for the systems that so we don't have wiring for the gunnery system and the extra computers and all that stuff that was available in the war. So these wire bundles would have been as thick as your arm, easily. 3 of them down each side of the tunnel. The airflow comes into the middle of the tunnel, and then there was ducts that came down and separated the air either forward or aft. So again, it's a pretty amazing system. Some of these angles and channels, the material is still used today on aircraft. The factory that this airplane came down, Plant 2 in Wichita, Boeing's original plant, and now Spirit Aerosystems owns it. Spirit builds 737 fuselages on the same plant in the same factory that built this airplane in 1944. Yeah, same assembly line. So, yeah, amazing. The back of the doors had a little angled kick, a little curved panel that aerodynamically would help hold the doors open. The doors are air operated. There's a little compressor for each bomb bay, and they open in 1 second and they close in about 1.5 seconds. We keep the system de-energized. It works because it's our only means of secondary retraction. We just push them closed with our backs and let gravity open them up. But we keep that system de-energized because we don't want to throw somebody across the ramp or cut somebody in half. But that was essential in the war, to keep the airplane as clean as possible so they could keep their speed up. And then literally right before bomb release, the door snapped open, the bombs came out, and the door snapped closed again. So the airplane stayed clean and fast the entire time. So this side of the aircraft, we've got our 2 pitot tubes, pilot and navigator on this side.
So, hey, Justin.
Co-pilot, actually in Bombardier also off of this.
Just tell me, watch everything.
Navigator, co-pilot on the other side. Static ports here. Of course, our nose art. Owen Hughes that painted our nose art was a sign painter in World War II. He passed away last week at 103. So we have the original nose art on a nose section we have in Wichita. It's a little more militaristic looking, not quite as recognizable as the original Disney character. But Owen hand painted that. He was parked under the Eiffel Tower on a C-47 during the war and painted signs for the Allies because the Germans messed up every road sign trying to screw us up. And then he painted a lot of nose art on Jeeps and tanks and trucks and airplanes as well. So he volunteered to come out and do this. So pretty impressive stuff, yeah. B29doc.com. If you can't remember that, just remember B29 and doc, put the two together, it'll get us there. Pretty good website with, there's a fair amount of restoration photos on there, access to our gift shop so you can get apparel, and we have a DVD series that shows basically what we have back at our education center. Gives a segment on how we got into World War II, Tony's story on how he discovered the aircraft and worked to recover it, a recovery video, restoration video, return to flight video, and then a segment at the end about education and getting the next generation involved. So it's a really nice video. Again, we can get all your stuff mail order. You can sign up for announcements. So if you're interested in a ride flight, you can sign up, and then when next announce a ride flight, you'll get a notification. So the seats vary from $600 seat in the back up to 7, up to 3 available in the cockpit section at $1,200, radio operator, navigator, and jump seat, and the Bombardier seat for $1,500. That's why we do the announcements, because it's usually the first one to sell. Everybody wants the Bombardier seat, but there's not a bad seat in the house. Every seat's great. So yeah, it's a great airplane to fly. He loves to fly. We love to fly him, show him off. Thanks for watching, and I hope you enjoy the video, and come out and see us next time we're in your area.